All right. Good afternoon, everybody. I am Zane Denmon, the CTO of Fortifly.AI, and I'm here to talk about Fortifly.Train. Maybe. There we go. Ooh, too far. There we go. So Fortifly.Train started as a Navy civil between two companies, HF Design Works, which conducts our human factors research and analysis, and Thayer Mahan, which I am a part of. I am the current head of artificial intelligence for simulation and autonomous systems. And Thayer Mahan is tasked with the challenge of facing the 101 challenge, which we say is how do we enable one operator to man over hundreds of autonomous vehicles all at once, which is how it led us to this SBIR. And the challenge here is there's a huge disconnect right now between what the state of the art in technology is today and the training to get people sufficiently trained to use those systems. There is an anecdote that I'll share that a lot of the pilots that we interviewed in phase 1 had said that they don't get the capabilities in a simulated environment until 6 months to a year after it's already deployed in the aircraft that they operate in. So that's what they call adventure training, which is very scary. And so this is the Fortifly AI team. We're consistent of AI gurus, human factors training, and aviation experts. So we also have the subject matter experts as well. And we have several of us are startup founders. And we actually, my AI team got acquired by Thayer Mahan to build out their AI ecosystem. But we've been working in Future Vertical Lift since 2018. And this is a really good challenge for us because they're developing these advanced teaming and technologies to create the tactics of tomorrow using the automation that we have today. And this is all in the backbone of sensor fusion. How do we get all of that information out in the world into a digestible format and present that to the operator without incorrectly increasing the cognitive burden that they face during their missions? And so, as I said, there's a huge gap between what the state of the art is today and the training that operators need to sufficiently learn how to use and trust in automation. In Future Vertical Lift, they're talking about reducing crew numbers, but also deploying automation. So the tasks just don't go away. They either need to be tasked by the pilot themselves or through autonomous capabilities, which we focus in these unmanned autonomous system space to say, how can we give a lot of the taskings off and hand them off to autonomous systems, but then how does that human and AI teaming loop be iterated over and configured? And so that's where Fortifly comes in today. So we have this sandbox environment in the corner over there is where our booth is. And we show you how to use and trust in these new technologies, such as artificial intelligence and multi-domain data fusion, just for starters. And what's really good about our system is that not only do we train the pilot to be able to use our autonomous systems, the autonomous systems learn from the feedback of the operator in real time as they're using the system. This is built on the backbone of reinforcement learning with human feedback, which is what ChatGPT uses, OpenAI's ChatGPT uses to learn as humans interact with the system. And so for programs like Future Vertical Lift, where they're talking about these advanced tactics, we need to bridge that gap between understanding and capabilities that we're developing today. And so this is a breakdown of Fortifly.Train, but I'll just go over this very briefly. So the biggest component here is our cognitive burden analytics and modeling. So compared to other companies and organizations that focus in on this cognitive burden analytics, they fall into one of two camps. Either they can do real-time analysis, but they can only do it for one metric, or they can do it for a variety of metrics, but they can't do it in real time. So that's where we form the two, where we do it in real time and we collect multiple metrics that go into the cognitive burden analysis, which is important because no one individual metric can sufficiently track cognitive burden. So from our simulator over there, if you ever come by and test it out, we track visual stimuli, fine motor, gross motor, eventually. Obviously, you won't be moving around too much. Audio, speech, heart rate and heart rate variability, and pupillometry as a branch of, or a proxy for cognitive burden. And so what we eventually want to do is understand how the user is using our system to verify that they're able to use this in the real world. So through iteration, our goal is to reduce that cognitive burden and have that objective measure through time to validate that they're ready to be deployed in the real world scenarios using these capabilities. And again, our human and AI teaming co-training and co-improvement loop iterates over each user test that we have so that the AI gets better alongside the humans that use our systems. I got it. What separates us in this domain is that our system is portable and yet affordable enough to increase the volume of users through the system. So it's very accessible and yet very portable to be able to use pretty much anywhere that you could bring the system to your liking. And so there's another component here about modularity and integration, right? We're not a software company, or we're not a simulation company rather, but we wanted to establish that we have this sandbox environment that we could validate our approaches in. What we're working towards in the next month, hopefully by the beginning of fall, we'll have our system modularized enough that we could integrate ourselves into any simulated environment, right? What's really great about having a sandbox environment is that you get all the ground truth to validate the cognitive burden, right? So we have an eye tracker, and because we have the back end, we could verify that you're looking at what you're supposed to be looking at, you're not dwelling too long in a certain area, and your gaze patterns are sufficient. You're checking your gauges, that sort of thing. When we go to integrate ourselves in other simulated environments, we need to start getting smart about how we track that cognitive burden through AI methods to give a proxy for that cognitive burden when we don't get that back-end code, that validation. And so this is just a little graphic of the cognitive load, and this runs in real time, which you could show in the demo back there. And when your cognitive burden hits a peak, and because this is in real time, we get that evaluation of how the user is performing in the simulated environment at any time. So we can do fun tricks like launching automated capabilities to reduce the cognitive burden. So for instance, if a pilot has to also manage over UASs, which is a real world scenario, we can automate the UAS's tactics while the pilot is focusing on aviating and navigating to reduce their cognitive burden, and then we could give them back control over the UASs. And so, again, our end game is to train the next generation of aviators, how to understand, use, and trust in the automation that we serve for them in future missions. The continual improvement between the human and the AI and their synergy together is really important, especially when we talk about implementing AI capabilities into the cockpit. And how do we track, if you're fancy into AI, data is our gold mine. So how do we track all of that data to validate our AI that serves the users and learn from that data that we get in real time? Our path forward to commercialization is to get Fortifly into the hands of the aviators. So we're working with the Army and the Air Force to get users through our system for both the civilian, commercial, and general aviation that could benefit from Fortifly. We also want to incorporate our dynamic real-time workload system into the existing aviation platforms like the U.S. Army's Aero Medical Research Laboratory and the U.S. Army Combat Capabilities Development Command. And we want to be able to use that knowledge that we have from the different domains, from the DoD to the commercial, to also look into other verticals, such as the medical industry or manufacturing. Thank you all for the presentation.